Yeah, do you guys want to give us an overview of, why the application was picked over deployments, for example, like what application means for an Argo CD, not project, for Argo CD in general, and like how we can group, how we should group our resources underneath an application.
Yeah. Since Andy is running through an airport right now, I'll give an overview, and Andy, you can chime in whenever you feel like I missed something, or
Let's give
correct me.
him the space.
Yeah,
He
yeah,
needs
yeah.
through security and
Yeah, exactly. Yeah, get through security. So yeah, chapter 4 introduces the concept of an application, right? Like we can kind of talking about over the past few weeks about like Argo CD and applications and resources and blah blah blah, but like getting down to like what do we mean when we say application? So when I say applications is like a capital A application, I always say we have capital A application, which is like an Argo CD means a collection of Kubernetes resources, right? And so
yeah,
it's a CRD, right? But it's the smallest unit that Argo CD works with, right? Like you can't use Argo CD to just deploy a deployment
yeah,
without an application, right? Like you have to have this thing called an application, right? And so if you think about I'm gonna go over a little bit like kind of the Kubernetes kind of background, right? Whereas Kubernetes, it has like various controllers managing various objects, right? And so kind of like the primitives are like a pod, right? There's a controller managing a pod. There's a controller managing a
yeah,
secret, right? There's a controller, like in really in a declarative way, right? And so, you say, hey, like this service, you store it in etcd, right? When you apply something to Kubernetes, right, you're actually storing it in etcd, and the controller takes care of making that true, right? Which is very, very, very powerful. But all these components, you need like all these components together to make up your application, right? Like they're like loosely coupled is what I say. And I think I mentioned that in the chapters. Like you have all these kind of loosely coupled objects that actually make up your application, right? Like that make up,
yeah,
like if you're I don't know, if you have like WordPress, right? You have like the WordPress, all the objects that make up WordPress plus all the object that makes up the database, right? Like, and these are kind of like loosely coupled together, that are managed independently, right? And so
yeah,
the idea behind an Argo CD application is like kind of going a layer on top and saying, hey, this collection of YAML manifests, I want you to manage it as a single unit, right? Like, so basically you're managing YAML, or JSON, whatever, right? But YAML, like, well, I'll just use YAML in general. You're managing all this YAML as one entity, as one object, right? And so the idea of an application is like, okay, like you're calling this an application, right? Like this is and that's kind of like the idea. It's very, very simple in terms of minimum type of configuration. And I'm glad you have this up. This is like the minimum type of configuration is basically
yeah,
you give it a source, you give it a destination, right? You give it, and basically that's it, right? It's like, here is all my YAML and here is where I want you to apply it, right? And so the source could be a customize, a Git repo with a bunch of customize in it. It could be a Git repo with just a bunch of like straight YAML. It can be a Helm chart. And then now, hopefully in the next couple of days when Argo CD 3.1 gets released, we're a little behind, but it's okay. You can also do OCI, but basically it's kind of like, this is where you grab the things, right? And this is the
yeah,
destination.
yeah,
And I want you to manage, you meaning Argo CD, I want you to manage that as a single atomic unit. And so from a high level, that's kind of like what an application is, right? Like you can think about it in terms of like I think the original idea was like, think about them like as a microservice, right? Each microservice is basically an application, right? I kind of use WordPress, and that's kind of like a bad example because really you're going to manage the database separately from like the front end.
I mean, Christian, it's almost the same as thinking back to a Helm chart back in the day when Kubernetes was young. Same thing. Even though obviously you can manage a Helm chart with Argo CD. We'll get into that a little later on.
Yeah, certainly. So everything that happened to dangle in the whole namespace, and like that, you have to look and understand, or like, I don't know, by labels or something else that you try to connect, now actually has some sort of relation to each other through Argo application that actually can be even handled by the sync options or like the SyncWaves, etc. And how does Argo CD handle the drift now? Because now our code will change, the cluster state will remain the same. And how does this work between Argo and our actual resources?
Yeah. So and like if you, I think in this chapter we go over it a little bit. I think it might be
In later ones, I know we go into a little bit further detail.
Yeah. So by default, so like if you go up up to the when I said like the minimum, that one. So by default, if this is all you apply, Argo CD actually doesn't handle the drift, it just reports the drift. So if you make a change in Git, the repo server, right, goes and say, oh, there's a new version, in Git. Let me download that and let me compare it with the actual, the application controller then grabs that new state from the repo server and compares it, and it'll just report to you that there's a drift. Also, if there's an out of band change, right, like if someone does kubectl scale, right, your deployment, it'll report that, hey, there's a difference on the cluster, right? So it'll say it's like out of sync from the repo or out of sync from the live state, but it'll just report it, right? So like by default, Argo CD, like if you just have this minimum, kind of source destination, the it just reports it, right? So far we're like, not even in GitOps territory, we're kind of like in DevOps cluster management territory more than anything. From there, a user can decide to sync or not.
And also there's this source and destination concept, right? Here we define the repository and the branch we'd like to base on, and path within that repository, and then we have to tell which destination cluster we're aiming right here, and the namespace. But Argos, the Argo CD application lives within this namespace, right?
It lives within the same namespace that Argo is deployed in. It doesn't have to be tied to Argo, potentially, but it's whatever the namespace Argo is deployed within.
Yeah. So it's wherever Argo is installed by default, and I think it's because of documentation we kind of just recommend everyone to install it in a namespace called Argo CD, but it's wherever Argo CD is installed. Yeah.
Yes.
There is a new feature that we'll go into a little bit later on called applications in any namespace, where it's not restricted to just the namespace Argo supports within.
Yeah, I remember being this a bit of a confusion when you're starting and trying to understand, where everything goes. Also, I think there was a conversation around the number of applications sitting in a single namespace becoming a bottleneck when in the UI, and I guess there was already a design doc for this. Cool. And I really would like to go to the 5th chapter as well, so I'll try to be mindful of the time because it's a great chapter, that one. So application resources. So yeah, how do we get the desired state defined? So did we discuss Git and Helm here? Do you want to go a little bit in this?
Yeah, just high level. I think we went over it a couple weeks ago, but it's worth repeating for those who weren't there. Is basically you have the source, which could be in Git, or in Helm, right?
Yeah.
And you can mix and match these, right? Like you can have like Helm in a Git repository, right? And Argo CD will figure out like, oh, you know, you specified Git, but you're actually using a Helm chart, right? It'll do the proper. It has kind of like auto discovery, right? Another destination, right, that we didn't discuss here because it wasn't available at the time is OCI. So
Yes.
that's sorry, a source. A source can be OCI repository as well.
Yeah. Yeah. Sorry.
So
Yeah.
you know, but by the time that
I remember
yeah.
seeing it mentioned somewhere, but I don't
Yeah.
know.
So originally the only way to get OCI is through Helm. So it wasn't
Yeah.
technically OCI, it was Helm. And if you happen to that Helm chart happened to use an OCI repository.
It was kind of it was basically it wasn't OCI native. It was OCI's functionality within Helm. You still need to use Helm. You can difference the chart from an OCI destination to have a traditional Helm repository.
Yeah. Yeah. And then we have the destinations here. So it's basically how you tell your application to be on a cluster. Is multi-cluster setup possible here? I'm
Yeah.
not entirely sure. Can we give multiple
Oh,
destinations?
well, in an application configuration, no. An
Okay.
application configuration, you would have to use, and we go over it in a little bit, but when we talk about application sets, on chapter 10, I think we were going over applications at scale, is the name of the chapter, but it's, but no, like if you're just using the one configuration, the one application manifest, you can only specify one destination.
Right, cool. Also, the namespace, there is a mention here that doesn't, the field doesn't overwrite the metadata namespace field if they're declared within your manifest. So I think that's one of the important things to note.
It's important and kind of like just they're like independent, right? Like a lot of people say namespace. I mean, now it's less confusing as people are adopting Kubernetes more and more. But like originally, you're like there's like all this namespace like embedded in it. So that's just kind of to call out that it's not they're unrelated.
Yeah. Okay, cool. Also, then how you delete these applications, right?
So there's
to finish this chapter. And also there is an interesting notes here I'd like to touch, like how Argo CD deletes resources. But yeah, please go ahead.
So I think the main thing from deleting applications is the finalizer, right? And so there's this concept of an application deletion and a cascading application deletion, right? Meaning, so like if you just delete the application resource, and if you delete the application resource and you did not set a finalizer, it'll just delete the application definition, but it'll leave everything it deployed there, right?
Yes, I wish I had seen this.
Yeah, it won't delete any of the resources. Yeah, it won't delete any of the resources.
It was a Friday evening when I was just dying and trying to understand why the resources were still there, but my application was gone, and it felt like things were just up in the space without an application now. But I think. So what happens? Do I need to imagine I forgot to put a finalizer? What happens? Do I need to take care of those resources one by one by myself? Or
I mean so like I think the cleanest way to do it is like to go to those resources, delete them one by one. Another thing you can do is just reapply the application with the finalizer in it and then delete the application. So that's kind of like the default. It won't do that. There's a way to overwrite that, like in the Argo CD CLI, right? You can like actually tell it to do a cascading delete. So anyways,
this is the finalizers. Finalizer.
So like you should add. So like if that's what you want, right? Like if you want the application to actually control the entire life cycle, add the finalizer. I add the finalizer.
I wonder why it's not coming by default, to be honest. Like, I don't know how.
That was the original design, right?
I think it's because to avoid just cascading deletes, if you go, I want to delete the application, but not delete the actual stuff underneath it. That's my guess.
It's
safety net a little bit.
Yeah, I guess it's about still having the last chance to people to just keep the resources somewhere, I believe. But yeah, it also has its own like confusion here and there. So use finalizer guys. Don't forget them.
Yeah.
Otherwise, you'll have to go. Well, reapplying the same application works. So yeah, I think a good enough solution. Yeah. So this was a chapter where you guys touched the application, the smallest unit in Argo CD, and now we're gonna actually take a look at how to synchronize applications. And it is one of the interesting and important topics in Argo. There are a lot of options, lots of flexibility, which I really like. And yeah, but by default, I guess it's manual, right? If I'm not mistaken.
The default is, so like if you just give it like that minimum spec, it is a manual sync, right? And
Yeah.
so there's a way, like either through the UI or through a YAML, you can actually tell it like, you know what, I'm going to give it a sync policy, right? So a sync policy is able to control how you sync an application, because you may want to sync one application one way and another application another way. So there are
True. Yeah.
so basically this is kind of the reason why like the sync is kind of by default disabled. And then when you add a sync policy, then you can just start manipulating how an application gets synced, right? And so and that's in the sync policy.
Yeah.
And there's different ways. I believe we go over a few options about
Yeah,
how
yeah.
applications are synchronized.
But before that, I think I got a bit fast. So what does sync do in the for an Argo CD application? And what happens in the background? Like you just shared that it tells Kubernetes that the resources should be synced. But like what happens in the background could be a nice thing to touch, I think, right now.
Yeah. So what happens in the background, right, is that the repo controller is responsible to download any updates from your source of truth, right? So like we're going to keep it very simple, but this applies across the board, is Git, right? You make a commit to Git, you change the replicas from 1 to 2 in Git, and then the repo server will detect that, right? So the repo server operates in a loop, right? In a continuous loop every 3 minutes, right? You can adjust that. But by default, is every 3 minutes it's going to go and check to see. It basically does a Git ls remote, right? Like if for those who know Git a lot, it basically does Git ls remote. It'll see the new hash. If the hash change, that means it'll actually do a Git pull, right? For example, right? And get the updated version of that, of whatever your source of truth is. And then from there, what the repo server does is that it renders the YAML, right? If you're giving it straight YAML, then it just kind of just spits that back out. If you give it customized, it's going to do a customized build, and then give that payload. If you're doing Helm, and this is where it trips up a lot of new users for Argo CD. If you're doing Helm, it actually does a Helm template, right? So this is in contrast to like Flux, where Flux uses the Helm SDK, right, to where it'll actually use that library. But Argo CD has the philosophy of dealing with raw YAML, right? So like no matter what configuration management tool you're using, it's going to render it, meaning it's going to have raw YAML. It wants raw YAML, basically, right? And so what does that mean, right, in layman's terms? So that means just basically if you do a Helm ls on an Argo CD system, it's not going to return anything, even if you have 1,000 Helm charts, right? That's basically what it is, because you're just Argo CD is dealing with raw YAML. So repo server, one, it checks to see if there's any new changes. If there is, it'll download those changes. Once it downloads those changes, it's going to render those out, right? So it's basically going to render those out to raw YAML. From there, the application server will pick up the change, right? So the responsibility of seeing changes is actually not the application server, but the repo server, right? The repo controller responsibility.
Yes, that's great. We have 2 questions actually. Let me. I don't want to, forget them. Is the default method still the same? I mean, foreground deletion instead of background, coming from Benjamin. I think it's about the application deletion we discussed. Yeah.
Yeah, I believe the default is foreground. I believe so.
It is. It's foreground.
It is, right? Yeah.
What does foreground background deletion mean here?
Foreground means that it's going to basically hold the CLI until all the resources are deleted. Background means it's going to basically almost when you delete a pod, it kind of just says, I've deleted it, but has it really deleted it? Maybe.
Yeah, it's a blocking versus non-blocking operation, essentially.
Yeah, cool. And Francisco is asking if the application code is in a report that requires authentication, and it should. How is it managing authentication?
Yeah, I think I go over it a little bit more in later chapters, but the idea is that you give it the configuration, right? And so there's the credentials is managed in a secret, right? And so if you put those credentials in the secret, the repo server will use the secret to authenticate.
Yeah. All right. Let me just switch to the book. It's actually quite straightforward, Francisco, and quite easy to set up when you're setting up the repo server. And now we have the sync options in this chapter. So as you just shared, normally it's by default manual sync, but we actually have a lot of options, for example, also different levels. So as you shared here, there is application level and resource level options.
Yeah.
Can you explain a little bit what this means?
Yeah, so there are sync options that apply to your application as a whole, meaning to every single YAML you have. And there are options
all of them here,
there are options that apply that you can only set, not only set, but if you want an option to apply to a specific YAML, so like one object, right, for example. And so for the more and like these overlap, right? There are a lot of them you can do either or. You can apply it to the application as a whole or to an individual object or an individual YAML, or but some of them are only being able to set on the application level or on the object level, right? And so there's a few options there that are see, my favorite one is actually ironically it's the validate, wait, let's say skip dry run on missing resource, right? Right now that is only applicable to individual objects, except in 3.1 they actually made it shout out to CodeFresh who wrote this in. It's an actual global sync option, because I always use that as a global sync option. And the reason is that and Andy can attest to this, is like sometimes things like OpenShift or things that are like an operator focused, like you're trying to apply a CR, but the CRD isn't there. Argo CD will fail on that. And it'll fail continuously, right? Because it'll actually do a dry run before applying. And what I say is skip the dry run, just keep applying until it's successful, right? Like, so basically I use what do you call it? Eventual consistency. What's really, really cool about skip dry run on missing resource is that if the resource is there, it'll do the dry run, right? So it'll only skip the dry run if it isn't there, but if it is there, it will do the dry run. So it's basically a harmless option. So that's kind of one of my favorites. But
the first one you discover is create namespace, though, I believe.
Well, that's the one I always use. Create namespace equals true. Like I always just kind of manage the namespace in Argo. But there's a bunch
cool,
of
actually.
there's I think a lingering bug where if it doesn't delete the namespace, you have a bunch of lingering namespaces, but it will create it. But there's a bunch of options there.
Would it fail if the namespace is there the second time you have the same option? Okay.
Nope. No. So there's a bunch of options there that you can set. You guys can read that, but it's basically you're modifying how the sync behaves, right?
I'm not sure if I've seen this before. Server side apply. Interesting.
I like server side. I use server side apply a lot if I need to make small minimal changes to resources without overwriting some of the entire struct. It's very helpful.
Yeah. Also, I think respect ignore differences is one of the important ones because it gives you some room for not Argo going mental all the time and trying to change something, right? Like, can you explain it further a little bit?
Yeah, so ignore differences, and I think I go over that in different in either in this later in the chapter or a different chapter.
In this chapter we will actually touch it again.
Yes, so basically, ignore differences is like if you want Argo, when Argo does a compare, you can tell it, hey, like ignore the differences, meaning like if I'm gonna make a like if you're using like HPA, right? Like if you're using the pod auto scaler, right? In the deployment, you kind of want Argo to ignore the spec replicas, right? Like you want to ignore the replicas because you're managing that, right? Outside of so you could say ignore difference, spec replicas, right, in your deployments. But that only ignores the difference in the comparison, but not the sync. So when the sync happens, it'll actually try to revert it back to whatever you have it in Git instead of ignoring it.
Okay.
Yeah. So it's only ignore differences is only in the compare. I guess it's the high level. It's only when you're comparing running state to desired state. But if you have the respect ignore differences off, it'll when you said respect ignore difference, it'll actually also respect it during the sync operation. So both. So then I think, and that's kind of the behavior most people wanted. So that's actually another. This is a good one to call out for sure.
Yeah. And then, as you said, we can still manage resources separately in an application. Which one? So I'm guessing the one on the resource level would actually take over, right? It wouldn't go the other way around. Like the application wouldn't force the sync options onto a separate resource, singular resource.
Yeah. Correct. The one on the individual resource takes precedence.
Otherwise, it wouldn't work, obviously.
Yeah.
And they're managed through annotations, as far as I can see. Yeah. So we have validate, prune, last, replace, and server side apply. Then we actually now can discuss order, sync order, and hooks. So hooks are pretty important to actually do things before, during, or after, right? Can you talk a little bit about this one?
Yeah, sync order. So like really like there's two frame of mind here, right? So like there's the sync phases, right? And then where the hooks are, and the sync order, which we go after, right? So like if you thinking about hooks, you need to think about the different sync phases of an Argo CD sync, right? Like when you click sync, or when an auto sync happens, or when you do it from the CLI. Anytime an Argo CD does a sync, it does it in 3 phases, right? It does a pre sync phase, right, where like it does the actual sync phase, and then there's a post sync, and there's also a sync fail, but we will go over we'll go over that more in depth. But those are like the big 3, right? And so if there are things that you want to happen before a sync operation happens, you have to, or like, or the biggest use case is you want to run a job or something that does something, right? Like, I don't know what, right? But it does something. So you annotate your job saying, hey, this is in the pre-sync phase, meaning that these manifests will get applied before the actual application syncs. right?
Mm-hmm.
And then there's stuff in the sync phase, right, which is like the default. If you annotate a job in the sync phase as like, hey, run this in the sync phase, it'll run after everything else syncs, right? But before the post sync, right? So that's kind of, you have to think about it in that phase, right? And then the post sync is like anything that you want to happen after a sync happens, right? There are other quote unquote special phases, right? Like there's like a post delete phase, right? Where basically when you delete an application, you want something to happen after you delete an application, or if a sync fails, you want something to happen after a sync fails. Those are kind of, special ones, but you think about it in 3 phases, right? There's 3 main phases: pre, sync, and post.
Yes, and yeah, also there's this hook delete policy annotation, right?
Yeah, a lot of people get tripped up, and it's very, very good to call out is that, well, because like they'll put a job in the pre-sync phase, right?
Yeah.
And then it'll run the first time, but when you sync again, it won't run again. It's like, well, why didn't my job run again? It's like, well, nothing changed, right? It's still GitOps. You have to remember, it's still GitOps, right? It's not going to run each time you do a sync unless there's a change, right? Like unless you actually change that job, manifest, that job YAML. And so what we tell people to do, and I don't know, maybe someone can tell me why, maybe Andrew can tell me why a little bit. Like they're hesitant to do this, but basically a job, once it's succeeded, you tell it to delete that job, basically. So basically run the job, and then once it's successful, it'll delete that YAML. And so when you run it again, it'll like, oh, the job's not there. Let me reapply that, which then forces the job to run again, right? Essentially,
it's really due to the garbage collection, trying to clean up resources in the cluster. But yeah, I can definitely see there being challenges around that.
Yeah. And so, so anyways, there's like a hook delete policy. It's like, what do you want to happen to this job after it gets up, after it successfully runs? Do you want for it to delete, right? Or do you want it to delete only when it succeeded? Do you want to delete only when it failed, or before the next one runs, right? I think before hook creation is a good one, because it doesn't delete it after it runs, but it'll delete it before the next one runs. So it's kind of like a delete. It's basically another way of doing replace, right? Because what we were telling people to do originally was say, hey, I think that was the issue where people were like, oh, that feels weird, is say, oh, just annotate annotate it with replace, right? Because by default Argo CD does kubectl apply, but if you have that annotation with replace, it actually does a kubectl replace, right? Which basically just deletes the resource and recreates it. But that's a little scary, especially if you're doing CRDs and stuff like that. So this is just another way of doing that.
Yeah. Before we move on to SyncWaves, we have another question. Can you explain the server-side apply option a bit more, from Jerry?
Yeah, server-side apply is the apply happens on the Kubernetes API side. So that the reason why that's important, or let me give you actually a use case, right? So if you are going to apply a Kubernetes YAML, you have to actually specify the entire YAML, even if you're going to make one change, right? If you're doing it through kubectl. But with server-side apply, you can actually only give it the patch, right? You can only give it like, a spec replicas, right? Like you only have to give it just very, very minimal, and it'll actually do a server-side apply, meaning it'll grab that and it'll apply it on the server side. You don't have to have it locally. So it's basically, it applies it on the, like what it says, on the server side instead of like locally. So instead of Argo having to have the entire YAML, it could only have a piece of the YAML.
Right. Jerry, feel free to turn on your mic if you have further questions about this, by the way. Don't feel a stranger. Thanks, Christian. And I'm going to go back to the SyncWaves. This is how you tell Argo CD the order of things to run, right? Like to be provisioned, but started. But the thing is, I wanted to ask like how this works. So we have eventual consistency at hand. Some systems actually rely on that Kubernetes will get to the state that you are telling it. But here there is also a different, a new idea that I actually want a certain order, and I want to be able to manage the eventual consistency a little bit, right? What kind of needs actually made Argo CD to build this, right? Like, what was the request, or like what is a real world scenario? Yeah.
There was some precedence first in the Helm community, because there's a Helm and its own hooks that it used to order in certain ways, because you want to potentially run certain actions in a particular order. You want to run things, a database initialization job. You want to hold up the resources from being applied. And then you can also apply them at different phases, a pre-sync, a sync, and a post-sync. It allows you to really coordinate when within the lifecycle of an application you want to apply certain actions. And then you can order them. There's three phases, and then within each phase you can actually order individual resources depending on how you want them to apply. So you have some real good flexibility, and I find that it actually is a lot more powerful than Helm itself for the control that you can give on your resources.
Yeah. Is there any trade-offs we should be aware of when using SyncWaves against a fully eventual consistent, tool, let's say? I think Crossplane was working this way. I'm not sure, but
yeah. So another thing you got to remember is that, like I mentioned before, Argo CD does a validate and a dry run before it applies, right? And so eventual consistency may actually not actually work the way you think it does in terms of Argo CD, right? You have to actually like mess with the flags and mess with the options a little bit, right? You have to like turn on retries. You have to turn on dry run on missing resource, and then it will eventually be consistent doing it that way, right? If you don't want to turn those things on, right? Like, oh, I feel a little nervous turning off skip dry run, right? Which you shouldn't, but let's just say you are, right? I'm telling you shouldn't though, but let's just for the sake of argument to say you are, right? You can then tell Argo, okay, apply the CRD first, wait until it's healthy, and then apply the CR, right? That's I can see the argument of that being a little cleaner. You and in some cases you actually almost need it, right? So this is a very old frame of thought, because I think Istio, Service Mesh switched to their ambient mode recently, but it used to be where Istio needed to be installed first.
Yeah.
Like absolutely, because if you install the app first and then Istio, it doesn't install the sidecar. You have to like restart the app, and like in Argo CD, you get kind of weirdness, right? So this is kind of a good thing where SyncWaves came in, where it's like, okay, just make sure these resources are up and running, because there are things other than CRDs and things like that that need to happen in a certain order, right? And so for the attendees, like for our attendees today, SyncWaves are basically the order you can define through annotations within your resources in one application. So you can tell, like here the example is create namespace as way -1 and service account 0 and deployment as way 1, so that everything works in a certain order, and they will fail, right, if the previous one fails. Well, the previous not that they would fail,
they will not
like,
be created, but
they won't, the sync will stop if like there's any failure, right? It's like apply this first, wait until it's healthy, which is it's really important. It just does apply it first and moves on to the next one. It'll apply it first, wait until it's healthy, or Argo CD considers it healthy, and then it'll move on to the next one. and you do that in whatever order you set, right, from smallest number to biggest number.
Yeah. Also, we can get them working with the hooks, right? And so this one was like so a pre-sync hook that has resources, so it can be applied in a specific order, and in that phase, without affecting other hook phases, you can actually create some order. That's also amazing. So yeah, I would like to encourage everyone to use test the use case. It's a really good example of what SyncWaves might bring, like can help you in your applications, because it starts with a database. But first, I would actually go to the comparing options and all that. But at the end of this chapter, if we can't make it all the way there, folks, please try it. I think it works on kind. The project in the book, the repository in the book, is actually quite straightforward and really nice to play with. And now SyncWaves, yeah. So we can have a database, then after that we can create the objects we want within the database, and then after that we can create, I don't know, the service and application, backend, front end, maybe the latest. And comparing options is an interesting feature as well.
Yeah, you can basically you can change how things get compared, right? We kind of talked about ignore differences, right? There are other things where and I think this I ran into this when doing OpenShift, right? Like OpenShift controllers manage like spin up and manage other things, right? And so which Argo may see as I'm like, oh, that's out of sync, like it's not defined in Git, but like you do want operators to manage their things, right? And so there's something like called like ignore extraneous, meaning like, hey, if this controller creates anything, just ignore it, because this controller this controller, or like there's an operator that manages these resources, and I'm managing these extra resources with the operator, right? So like don't worry, basically don't worry about these resources, just worry about like the operator, CR for example. That's that kind of like that use case that for comparing options, like you can say, hey, just ignore extraneous creation. So kind of call that out, like, especially if you're using operators.
Yeah. I also forgot to mention the health checks. To get SyncWaves running, you need proper health checks depending on the type of resource, right?
Yeah, so I actually go over that a little bit.
Yeah, we go over it in pretty good detail, actually.
I go over it at when you're doing, I think, app of apps, right? I think applications at scale.
Oh, right. Okay.
Chapter 10. The SyncWaves, the health checks, and we can go over that deeper later, but those are very, very important because there's built-in health checks with Argo CD. But if you created a new CRD, there's no way for Argo to know how to check the health status, right, of like your CRD, or if there's a brand new chart or whatever. But yeah, I go over that in detail in chapter 10 for sure.
Yeah. Also, we have a question from Benjamin. That's why I scrolled up in the book. The namespace having wave -1. What's the idea here, having negative
so it's just so you can have more control over the sync options, right? But basically, the lower the number, right? So in negative is you can go lower and lower, the more priority it has, essentially.
I thought when I saw this one, I thought it would be more around I really don't want to change anything. I just want to put everything behind 0, and like if
Yeah.
something comes up before -1, I will just go negative with something they provided, like flexibility. But yeah, okay. So
Yeah. And
if we see minus in the waves, should we take this like, okay, this is something important, right? Can we go
well,
like all the way,
it's
or
or
is it
yeah,
just it ends
yeah.
with at
It's just like it'll go like it'll start applying to the least value to
right?
the most value first. Essentially, it's just a way of
Okay.
ordering.
Okay. Right then we have, yes, we discussed this, and managing resource differences again, application level diffing and system level diffing. We have like 2 minutes, but yeah, if you could just share a few sentences. I think we did really
Yeah.
well covering 2 chapters today.
Yeah, application level diffing is basically I want like I want this diff you know to behave only for this application. And the system level one is like I want every application to
Yeah,
ignore these differences. Essentially, that's basically it's like do you want it to ignore it at the application level or do you want to ignore it as your entire installation wide?
yeah, yeah, yeah. And yes, here we can see this. And the demo application, folks, is quite fun. Let's have a look at this. I think I have it here. So in chapter 5, you will be able to see the price list app, and it has a finalizer. So I'm really
Yeah.
pleased. Uh, and it has, yes, the sync policy and some options as well. But what it does is actually in these manifests here, because sorry, that's where you set the path. So in the manifests, actually, when you start looking, there's also this order, but if I don't provide a SyncWave number, would it actually check this order here? Is there a
No, that's
reason behind it?
no, it'll this just using customize.
Right.
It'll do a customized build, but the order that you place in customize doesn't matter to Argo CD. It
Cool.
matters if you're not using SyncWaves. Sorry, let me rephrase that. Since we're using SyncWaves, that order
Oh
doesn't
yeah,
matter.
yeah. That was my question. If I didn't use SyncWaves, this would be the order to apply these
Well,
resources. Was my question.
technically,
No.
customize has its own
No, right.
order.
Yeah.
Yeah,
Okay.
there's a customize option where you can put I think it's called sort option first in first out, or I forget what it's called, but anyway, customize by default has its own order
And so,
that
and so
that
does
it does.
Helm. Helm has its own as
Yeah.
well. So each individual tool
Yeah.
has its own precedence for what resource to add and what order.
Yeah. Let's quickly check the resources. So we have the persistent volume claim here and in the SyncWave 1. And then 2 has the service, but I believe I saw 1 somewhere else. So you can actually group
Yeah.
resources in waves. So it doesn't have to be like I have just a single resource in each wave. You do group them, right?
Yeah, you
So
can
we
group them,
have
yeah.
we have the database deployment here with all the nice and juicy details. So it actually needs it has the health checks as well. So it has the liveness and the readiness prop here. And then, then we have the SVC, the service in the wave 2. I'm going to go on to this one. Sorry, I think in wave 2 had just 1 object. That would be a really nice thing to add a diagram there. Maybe I missed it in the book. Like how the order. Oh yeah, okay, we have the table. Great. So the PVC and DB in wave 1, SVC in wave 2, deploy, and this and the job. but it's in post-sync hook in SyncWave 0. What does it mean actually?
Yeah, so post sync, so every sync option, every sync sync wave it operates in each phase, right? So like if you have a 0 in a sync but a 5 in a pre-sync, the 5 is going to go first because you're in a pre-sync phase. So
Yeah.
they're basically scoped within each phase.
So phases come before the waves, right? Like override the waves. That's, I don't know, bigger than the wave. Sorry, my
Well, yeah,
English
well,
is
because
going.
it's so if you think about it, there are 3 distinct operations and they happen in
Yeah.
that order. So the wave just happens to happen in. It's not necessarily it overwrites it. It's like you're in a different.
It's a phase. It's a phase, basically.
Different phase.
Yeah.
Exactly. Okay, that's very clear now. Thank you. And I really don't want to keep it longer. Let me stop sharing. Folks, if you have questions, our authors are in Kubernetes book club Slack channel, so keep them coming. I feel like this has been, we got into the juicy details of the power of Argo CD today, and we'll get them coming more. So thank you, Christian and Andrew, for this very detailed session. And the book, the chapters were great. And I'll see you next week.
Take care, everyone.
Cheers, everyone. Have a great week.